Right, I'm not sure if there's anyone. That might just be myself. So if you connect, that's annoying. Okay, we seem to have a stable connection now. Is there anyone out there? Good, somebody's out there, so we'll start again. So a few technical problems there, but we can get going. Today I'm going to look at a couple of algebra topics, quadratic equations and simultaneous equations. These are kind of more of interest to the older students, although certainly from MYP 3 it could be interesting because it's quadratic equations is something I first teach at the very beginning of MYP 4. Simultaneous equations is something I teach at the end of MYP 3. But it could be interesting for anyone, but it will be a little bit higher level today. At the same time, do email me, JJC at the school, you know the address for that, if you've got any specific queries. And nothing today yet. Only one viewer, so give me a thumbs up if you're there. No thumbs up. Okay, I'm going to wait anyway. So in any case, people can watch this back. Oh, there's a thumbs up. Brilliant. Somebody there. Okay, good. So quadratic equations, 2 viewers, and quadratic equations. So if you're watching out there from MYP 1, 2, and 3, you won't have done this. For MYP 4 and 5, this will revision. Plow through with it anyway. So I've taken something from my iMaths, and it's find the missing factor. So you've got x squared plus 12x plus 32. X squared, just make sure we can see that, plus 12x plus 32. Now I'm just going to remind you for a minute about multiplying times x plus 12, randomly brackets. What you have to do with that, if you want to multiply those brackets out so that you're writing something that doesn't involve brackets, then you're multiplying everything in the first bracket by everything in the second bracket. So x times x gives you an x squared. X times 12 gives you a 12x. And then the 5 times the x in the other bracket gives you 5x. And then the 5 times 12 give you 60. So those brackets are equivalent to x squared plus 12x plus 5x plus 60. And then the 2 terms in the middle, 12x plus 5x, we can put together to make one big term, 17x plus 60. So that's multiplying brackets out. And factorization is the process of trying to do that in reverse. So I'm going to talk about this in terms of it being revision rather than trying to teach it from scratch. I do have a couple of good YouTube videos on my channel if you want to see this taught from scratch, from the beginning. But I'll just remind you, that 60 came from the fact that the 5 times the 12 made 60 because we multiplied them together to get it. The 17 in front of the x came from the 15 plus the 12 because we did 5 times x and 12 times x and added those together. So the 17 and the 60 are factors of 60 that add up to 17. So trying to apply that process in reverse is the key to quadratic factorization. So here, going back to the question on the iMaths, I'm looking for factors of 32 that add up to 12. So I can do a little list of factor pairs of 32. So it could be 1 times 32 makes 32, or 2 times 16, or 3 doesn't go into 32. These questions are usually kind of nice whole number solutions. 4 times 8 makes 32. 5 doesn't go, 6 doesn't go, 7 doesn't go, 8 doesn't go, but we've already got 4 times 8. So out of those, the 4 and the 8 add up to 12. So we were looking for factors of 32. 4 times 8 makes 32. That add up to 12. 4 plus 8 makes 12. So that tells us that x squared plus 12x plus 32 factorizes into x plus 4 times x plus 8. And we can check that just by multiplying everything out again. So x times x will give us the x squared. X times 8 will give us 8x. 4 times x will give us 4x. And together they'll make 12x. And 4 times 8 will give us 32. So as I said, I'm not going to go into great depth explaining this or teaching it from the beginning. I'll assume that if you're watching this and following it, it's because you've done it in class before and we're revising for now. And as I said, there is a nice video, probably a couple of videos on my YouTube channel that you can dig out if you want to see this taught from scratch. Okay, so the first one on the iMaths was the one I just did. So it factorizes into x plus 4 times x plus 8, or x plus 8 times x plus 4. Doesn't matter which way around. And we've got an equation that has that equal to 0. And that whole thing will be equal to 0 if either of the things that we're multiplying together is 0. So the whole thing will be 0 if x plus 8 is 0. So x would have to be minus 8 to make that bracket 0. Or if x plus 4 is 0, x would have to be minus 4 to make that bracket 0. So that's that, and let's just run through the other ones on this sheet. These are quite nice, actually, because they give you one of the factors. Okay, so factors of 45 that add up to minus 14. So factors of 45 could be 1 times 45, could be 2 doesn't go, could be 3 times 15, could be 4 doesn't go, could be 5 times 9, 6, 7, and 8 don't go, and then we're back up to 9. But we've got minus numbers here, so we've got to bear in mind that factors of 45 could also be minus 1 times minus 45, or minus 3 times minus 15, or minus 5 times minus 9. And minus 5 and minus 9 add up to minus 14 that we've got there. So our factors of 45 that add up to, we're looking for them to add up to minus 14, because there's a minus there, are minus 5 and minus 9. And in fact, in the question, they've already given us the x minus 9 as one of the brackets. So the other bracket is x minus 5. So that gives us an equation, x minus 9 times x minus 5 equals 0. And the whole thing will be equal to 0 if either of the brackets that we're multiplying together is equal to 0. So x would have to be 9 plus 9 to make that first bracket 0. And x would have to be 5 to make x minus 5 0. So the answer is that x equals 9 or x equals 5. We can actually check that. That's the good thing about algebra. You can always take your answer. Let's say take the 9 and then check it back in the original thing. So 9 squared would be 81. 14 times 9 is, let's get the brain in gear, 126. So minus 126 and then plus 45. 81 minus 126 plus 45 is equal to 0. Let's try it with a 5. So x squared would be 5 squared, which would be 25. minus 14x would be minus 70, and then plus 45, and 25 minus 70 plus 45 is equal to 0, so it does work. Okay, I'm going to skip the last two of those. They're pretty samey, and go on to the second tab. So on this one, they don't give you one of the solutions, so it's just a little bit trickier. And there's a mixture of things with pluses and minus here. So there's a thing where both things are plus, a couple where one is minus, one in plus is plus, but in different places, and then one where they're both minus. So let's have a look at these. I'll skip the first one because it's fairly straightforward. Or shall I do the first one? No, I'll do the first one fairly quickly. So x squared plus 9x plus 14, we're looking for factors of 14 that add up to 9. So factors of 14 could be 1 times 14, could be 2 times 7, and in fact those are the only numbers that go. And 2 and 7 add up to 9, so our factors of 14 that add up to 9 are 2 and 7. So that means it factorizes into x plus 2 times x plus 7. So x plus 2 times x plus 7 equals 0. And to make the whole thing equal to 0, then either of the brackets need to be 0. And to make x plus 2 0, x would have to be minus 2. And to make x plus 7 0, x would have to be minus 7. And it's usually that bit with the brackets, the number in the brackets being plus, but then the x being minus to make the brackets 0. It's usually that bit that confuses people. Okay, I'm going to do the last one, and then I'm going to look at solving these in a different way using the formula. So the last one says x squared minus 4x minus 32 equals 0. So I'm going to try and factorize that. I'm looking for factors of minus 32. So factors of minus 32 could be minus 1 times 32, could be minus 2 times 16, 3 doesn't go, could be minus 4 times 8, 5, 6, and 7 don't go, could be minus 8 times 4, which is different from minus 4 times 8, could be minus 16 times 2, could be minus 32 times 1. So those are the factor pairs of minus 32. And then we need to look at those and see if any of them add up to minus 4. And in fact, minus 8 and 4 add up to minus 4. So in the brackets, we get x minus 8 and x plus 4. So x minus 8 times x plus 4 equals 0. X has to be 8 or minus 4 to make the bracket 0 and to make the whole thing equal to 0. And I've lost some viewers on that, so hardly surprising, but well done for staying. Do email in with any queries. I haven't received anything today. I got a nice few queries yesterday, which was good. And it doesn't have to be about this, just anything and everything really. Okay, so the other way to solve these is the quadratic formula. So generally, a quadratic equation goes something x squared plus something x plus something on the end equals 0. And we call those numbers a, b, and c. So your general quadratic equation looks like that. Something x squared plus something x plus something on the end equals 0. And the formula is x equals, I had to learn this when I was your age, minus b plus or minus square root b squared minus 4ac all over 2a. So you get that on the formula sheets in most exams these days. So it's not something you have to learn, although it doesn't do you any harm to do so. So the a, b, and c are just the numbers that are in front of x squared and x and the number on the end. And basically, this is just a rearrangement of this. So you start with that. There's a bunch of algebra you can do to both sides to rearrange it into x equals something with all the other letters. So if I wanted to do this one, just making sure you can see it on the screen. Yeah, I can see that. So if I wanted to do this one, x squared minus 4x minus 32 using the formula, then I'd be saying, how many x squareds have we got? We've got just x squared on its own. So a equals 1 because we've got 1x squared. How many x's have we got? We've got a minus 4 in front of x. So b equals minus 4. B equals minus 4. And then the number on the end is minus 32. So c equals minus 32. This is assuming that we're starting with something, something, something equal to 0, because this thing talks about so many x squared, so many x, and a number on the end being equal to 0. So assuming we've got something x squared, something x, something on the end equal to 0, then we can call those numbers a, b, and c and stick them in this formula. Now, the formula is good, but people get tripped up on minuses because there's minuses in the numbers we're using and there's minuses in the formula. So I've got minus b. B is minus 4. So that's going to be minus minus 4. Yuck. Plus or minus square root b squared. So that's minus 4 squared. Minus times minus makes plus. So that's going to be 16. Minus 4 times minus 4. Then there's a minus. Then there's a 4. Then there's an a, which is 1 in this case. And then there's a c, which is minus 32. And that's all divided by 2a, which is 2 times 1, because a equals 1. Let me just try and pick up my ruler. It is stuck to this. Ugh. Still no emails. I'm really struggling with this ruler. Ugh. There we go. Okay, so let's just try and tidy that up a bit. So minus minus 4, minus minus makes plus, so that's just the same as 4. Plus or minus the square root of 16. So I've got a minus in the formula, and then 4 times 1 times minus 32 makes minus 128. So I've got minus minus 128 because there was a minus minus already in the formula, and then a minus in the 4ac bit. So you can see why people, mathematicians, experienced mathematicians of all ages, trip up on minus numbers. And that's all divided by 2 divided by 1, which is 2. But fortunately, in exam type problems, they kind of set them up so that the answers come out fairly neat. So 16 minus 128 is the same as adding them, and that's 144. So you can start to see how this is going to be pretty neat, because the square root of 144 is a nice round number. So that's equal to 4 plus or minus square root of 144 is 12 divided by 2. So the plus or minus just gives you two answers. So it's either, let's go over here with this. I don't normally like the several equal signs in a line, but I'm making a little exception for this. Excuse me for a minute while so here we go. Okay, so 16 plus 12 divided by 2, or run out of space here, or sorry, 4 plus 12 divided by 2, or 4 minus 12 divided by 2. So which is equal to 4 plus 12 is 16. 16 divided by 2 is 8, or 4 minus 12 is minus 8. Minus 8 divided by 2 is minus 4. So our two solutions are x equals 8 or minus 4, which is exactly the same as we got doing it the other way, which is, of course, what we should expect. Okay, where are we now? So we're 1224. I think that's probably all I want to say on quadratic equations for today. I'm going to take a sip of my coffee, see if any emails come in, and then we'll do some simultaneous equations. Okay, so simultaneous equations. So simultaneous equations is where you get a pair of equations like that with two variable things in. So it could be x's and y's, but it could be any pair of letters. So here we've got two equations, and they've got two unknown things. So normally you have like one equation with one unknown thing, like 2x plus 3 equals, I don't know, 100, for example, and you just solve it step by step by doing things to both sides, like a balance. Take away 3, divide by 2, and figure out what x is. But with simultaneous equations, you get two or even more equations in two or more unknowns. So with the first equation on its own, 2p plus 3q equals 14, you could think of any number of values that make that work. So you could just arbitrarily say, okay, I'll make q2, so that bit will be 6. So that bit needs to be 8, so p would have to be 4. Or I could make p5, and then that would have to be 4. Q would have to be 4/3 to make it balance. But you can think of an infinite number of solutions to either one of the equations on its own. So 2p plus 3q equals 14. I can think of as many solutions as I like. Just pick up a random value of p and then figure out the q, what q needs to be to make it balance. And then the same with the other equation, 3p plus 4q equals 20. I can think of any old value I like for p and then figure out what q needs to be to make it balance. But the whole point with simultaneous equations is that you've got to find the two letters, p and q in this case, that work for both equations at the same time. Another word for at the same time is simultaneously, of course. And if you've got two equations in two unknowns, then generally speaking, there'll only be one pair of solutions that works in both. I say generally speaking because there is kind of an exception to that. If you've got kind of two equations that are effectively the same, like 2x plus 4x equals 100, double everything, 4x plus 8x equals 200, then that doesn't apply for this. But usually you've got two distinct separate equations with two distinct separate unknowns, and there's only one pair of values that will work in both. So lost a viewer. We were up to the dizzy heights of 3 viewers there, but down we go again. So 2p plus 3q equals 14. 3p plus 4q equals 20. I'm going to call those equations equation 1 and equation 2. Now the first thing I'm going to try to do is make something the same in both of those equations. So at the moment everything's different. I've got 2p's here, 3p's here, 3q's here, 4q's here. And the idea is to multiply the equations up so that something is the same in them. So I'm going to multiply, it's got an L in it. I'm going to multiply equation 1 by 3, and I'm going to multiply equation 2 by 2. So equation 1 is 2p plus 3q equals 14. I'm going to multiply everything by 3 in that. So instead of 2p, I'm going to get 6p. Instead of 3q, I'm going to get 9q. And instead of 14, I'm going to get 42. So I've just multiplied everything in that first one by 3. Now I'm going to multiply everything in equation 2 by 2. So 3p times 2 is going to give me 6p. 4q times 2 is going to give me 8q. And 20 times 2 is going to give me 40. So why did I do that? Well, the reason is to make the p's the same. So I saw that 2p and 3p would both go into 6p. So I multiplied by, because 2 and 3 both go into 6, so I multiplied by whatever I needed to do to get them up to the same thing, that they both go into 6 in this case. Okay, so I started with that pair of equations. I often like to bracket them together to show that they're a pair. And then now I've got this pair of equations, which I'm going to call equation 3 and equation 4. So the thing that you can do with simultaneous equations is you can take whole equations and subtract them from each other. So now I'm going to do everything in equation 3 minus everything in equation 4. And it's quite good if you've got this sort of a nice, neat layout so you can see what's going on and everything lined up. So 42 minus 40 is 2. 9q minus 8q gives me just a single 1q. I don't need to write 1. And 6p, take away 6p, gives me nothing. It disappears. So what I've done there is, by having made the p's the same and then subtracting one whole equation from another, I've eliminated the p's. I've made it disappear. And having eliminated the p's, I've got the q on its own. Q equals 2. So that's my first of the two solutions. I've now figured out that q equals 2, but I need to figure out what p is. So what I do is I'm just going to draw a very rough line down there. I'm going to take my first equation that I originally had, which was equation 1, and I'm going to substitute that value of q in there. So at the start I had 2p plus 3q equals 14, one of my original equations. I've since figured out that q is 2. So this 3q, 3 times q, becomes 6. So that becomes 2p plus 6 equals 14. And now I've just got a straightforward single equation with one unknown thing. So that's the sort of thing that an MYP1 could now solve. I can just say, okay, take away 6 from both sides. 2p equals 8. Divide both sides by 2 to get p on its own equal to 4. P equals 4. So I figured out that q is 2 and p is 4. And then the last good thing to do is just to check it in not equation 1, but in equation 2. Because if you made a mistake with equation 1, you'll probably make the same mistake again. So equation 2 was 3p plus 4q equals 20. So that's going to become, so I figured out that p is 4, so 3p will be 3 times 4, which is 12. I figured out that q is 2, so 4q would be 4 times 2, which is 8. And 12 plus 8 does equal 20, so we know that we've got it right, and we can go on to the next one. Okay, so I will do a couple more of simultaneous equations, I think. They do get kind of tricky with the minuses in, and you know, if you get some with minuses in, you've just got to be careful to keep track of them. let's go for the last one on this sheet, shall we? Still no emails. Do get in touch if you've got something you want me to go through. So 5m plus 6n equals 52, and 9m plus 9n equals 90. So that's the last, well, there's a word problem, but we'll look at that in a minute. That's the last straightforward one on this sheet. So that's a pair of equations which I'm going to label as 1 and 2, and I want to figure out what m and n are. So I usually make the first ones the same, so I'm going to make the m's the same, and I could just as easily try to multiply it up and make the n's the same. But 5 and 9, they both go into 45. That's why I said 4 and 5, 45. So I'm going to try and multiply these equations up so that I have 45m in both of them. So in order to do that, I'm going to have to multiply everything in equation 1 by 9. So I'm going to do equation 1, everything multiplied by 9. So 5m times 9 is 45m. 6n times 9 is 54n equals, and then 52 times 9 is, oh, there's a test for my brain, 468, I hope. We'll find out if I'm wrong at the end, won't we? And so that's everything in equation 1 multiplied by 9 in order to get a 45m, so that we can try and get a 45m in both equations. Next thing I'm going to do is take equation 2 and multiply everything by 5, because 9 times 5 makes 45. So multiply everything by 5 to get 45m in this equation. So 9m times 5 gives you 45m. 9n times 5 will give you 45n. And 90 times 5 gives you 450. Okay, so I'm going to call those equations 3 and 4. You know what? Before I do go any further with this, I am going to check that 52 times 9 is indeed 468, because, you know, that would be silly, wouldn't it, if I went all the way with that and messed up at the end. So 52 times 9, 468. Should have trusted my brain, shouldn't I? Okay, so having done that, I've got the same amount of m in both equations. So if I do equation 3 minus equation 4, then 45m minus 45m disappears. 54n minus 45n gives you 9n's. And 468 minus 450 gives you 18. Now, it just happened I did it as 3 minus 4 because the numbers in 3 were bigger than the numbers in 4. But if the numbers in 4 had been bigger, then there would have been nothing wrong with doing it the other way and subtracting, taking the whole of equation 4 and subtracting the whole of equation 3. So as long as you're kind of consistent and you're continually doing the same thing to both sides of any equation, then you're fine. So anyway, I've eliminated the m's and I'm just left with a single equation in one unknown. 9n equals 18. I don't want to know what 9n's are. I want to know what 1n is on its own. So I'm going to divide everything by 9. And because an equation is like a balance, I've got to do that to the other side as well. So 18 divided by 9 is 2. So n equals 2. So we figured out what n is. Brilliant. And then we're going to take that n and chuck it all the way back into the original equation number 1 and see if we can figure out what m is. So equation, I'm going to write sub in 1, substitute my solution that I've just found back into original equation 1. And then, so 5m plus 6n equals 52 becomes 5m plus 6 times 2 is 12. 5m plus 12 equals 52. So now I just want to figure out what m is by solving this single equation in a single variable. 5m plus 12 equals 52. I'll take away 12 from both sides to get 5m on its own equals 40. Then I don't want to know what 5m's are. I want to know what m is on its own. So I'm going to divide by 5. But because an equation is like a balance, I want to do the same on the other side as well. So 40 divided by 5 is 8. And m equals 8 is our solution. So if I was doing this with kind of MYP1, I'd be writing little notes on the side saying divide by 5 both sides, take away 12 both sides as well. But now I'm a bit older and a lot older. And with my nice clear layout, you can see what's going on. So I kind of don't do that if I'm solving something for myself. But as long as your layout is nice and clear, you can see that 12 is disappearing. So you can see you're taking away 12 from both sides without having to write little notes at the side all the time. Okay, so we think that's our solution. We think that m equals 8 and n equals 2 is the solution that solves both equations. But I'm just going to check that by putting those numbers into equation 2 and checking it does work. So 9m plus 9n equals 90 becomes, I'm going to need a new pen soon, 9 times 8 is 72, 9 times 2 is 18, and 72 plus 18 is indeed equal to 90. So we know we've got that right, and we can go on to the next one. Okay, so I'm going to do, I think, one more of those today, which will be the word problem, and then we'll call that it for today, unless anybody suddenly emails me in with any questions. So if you have got any specific questions, doesn't have to be algebra, just anything you've got stuck on in the week, then do mail it in. Okay, so the cost of 2 bunches of roses and 2 bunches of carnations is $21. So I'm going to say, excuse me, I'm going to call them not B, I'm going to call them R equals cost of the roses per bunch, and C equals the cost of carnations per bunch. So the cost of 2 bunches of roses and 2 bunches of carnations is $21. So 2 roses plus 3 excuse me, that's what happens when you're talking for an hour. 2R plus 3C equals 21 is saying 2 bunches of roses and 3 carnations, 21. 5 bunches of roses and 2 bunches of carnations is 36. 5 roses plus 2 carnations equals 36. So that's given us, that's 2 pieces of information that have given us 2 equations in two unknown things, R and C. So once we've got from the words to an equation, then it looks very much the same as all of the other questions. So 2R plus 3C equals 21, 5R plus 2C equals 36. Well, I think for a change, I'm going to make the second one the same. So I'm going to try and make the C's the same. So 3 and 2 both go into 6. So I'm going to try and multiply these equations up so that they've both got a 6C in them. So to get from the 3C to the 6C, I'm going to have to multiply everything in equation 1 by 2. So I'm just going to write here equation 1, everything multiplied by 2. And then to get from a 2C to a 6C, I'm going to have to multiply everything in equation 2 by 3. So everything in equation 1 multiplied by 2. 2R times 2 gives me 4R. 3C times 2 gives me 6C. 21 times 2 gives me 42. Then multiplying everything in equation 2 by 3. So 5R times 3 gives me 15R. 2C times 3 gives me 6C. And 36 times 3 gives me 108. So now I've achieved two more equations. I'm going to call them 3 and 4. And they've both got the same amount of C in them. So if I do a subtraction of one equation minus the other, then the C's will disappear. Now, looking at this, I happen to notice that the numbers at the bottom are a lot bigger than the numbers at the top. So it kind of makes sense to try and do everything in equation 4 minus everything in equation 3 this time round, just to avoid going too much into minus numbers. So 15R minus 4R makes 11R. 6C minus 6C, nothing, disappears. And 108 minus 42 gives me 66. So I get 11R equals 66. Could have done it the other way around, and I'd have got 4R minus 15R and 42 minus 108. So I'd have got minus 11R equals minus 66. It wouldn't have made a difference to the final solution, but you make your life easier if you can just kind of do it in a way that avoids going into the minus numbers. So anyway, 11R equals 66. I don't want to know what 11Rs are. I want to know what 1R is on its own, so I'm going to divide everything by 11. But because an equation is like a balance, I need to divide the other side by 11 as well. 66 divided by 11 is 6. So we think we figured out the answer that R equals 6. So now that I've figured that out, let me just pretend I've got a new page down there. I can substitute that 6 into my original equation 1. So equation 1, which said 2R plus 3C equals 21, becomes 12 plus 3C equals 21, because I figured out that R is 6, so 2R is 2 times 6, 12. So 12 plus 3C equals 21. I'd quite like to get the bit with C on its own, so I'm going to take away the 12, but because an equation is like a balance, I need to take away the 12 from the right-hand side as well. So 21 take away 12 gives me 9. 3C equals 9. I don't want to know what 3C's are. I want to know what 1C is on its own. So I divide everything by 3. And because an equation is like a balance, I've got to do the same on the other side as well. So C equals 3 looks like our solution. But just to make sure I haven't messed it up, I'm going to check it in equation 2. So equation 2 said 5R plus 2c equals 36. And that becomes, so r was 6, so 5r is 5 times 6, which is 30. 2c, c was 3, so 2c is 2 times 3, which is 6. 30 plus 6 equals 36. Well, 30 plus 6 is 36, so we can see that it all works. We got it right, and we haven't made any mistakes. Okay, so that was simultaneous equations preceded by quadratic equations. So a little bit for the older students today, sort of end of MYP3 and then more MYP4 and 5. For MYP4 and 5, that should be revision. If you're watching and you're under MYP3, well, I hope it was interesting anyway, and I hope you managed to kind of sort of follow it along. But certainly you'll see that in the future. Okay, it's 9 minutes to 1, and nobody's emailed me, so I'm going to sign off for today. And do email me if you've got any specific things that you want me to go through.